Hey, now I'm live. Sorry, y'all. Okay, Hangout on Air is live. This is the problem. Here we're looking at, we're also on Periscope. So let me put that up in here. At Math 4 on Periscope. Or, all right, I'm just going to keep moving on. So at 0 feet is where we want to know how many seconds. Does it take him 25 seconds? Does it take him 3 seconds? And so we go down, we go to our handy dandy quadratic here. And first of all, it's a quadratic function. It is not a quadratic expression. Technically, it's an expression, but it has an equal sign. So it's a quadratic equation. And it is in the form y equals or f of x equals. So it is a quadratic function, which means it can be graphed. And that's what we want to do. So here's our little graph. So what we're going to do is we want to know at time equals what, the height equals 0. So h of t is 0, and the rest of the equation stands. Negative 16t squared plus 16t plus 480. So now that we have a quadratic expression on one side of the equals and a 0 on the other side of the equals, we can solve for, in this case, t. The thing is that when you solve a quadratic equation, you are looking for the value that you can put into the variable that makes it a true statement. So in this equation, I can put any number in for t, but it's probably going to equal like 84 equals 0, and 84 doesn't equal 0. So I'm looking for whatever it is that the t is that I can put in that it really will equal 0. So I'm going to, the instructions read solve in factoring, solve using factoring. So in this case, I can go, okay, 16, and 480. I know because I previously fought with the number 480 that 16 goes into 480. So I'm going to factor out a negative 16 just because I don't want anything next to any negatives next to that t squared. So factor out a negative 16, and I have t squared minus t minus, and I believe it's 480 times 30. I'm sorry, 480 divided by 30 is 16. So yes, that makes sense. So now I have negative 16 times this new, much nicer quadratic equation or quadratic expression. And if I have a nice, neat quadratic expression that's a little calmer than that crazy one before, I can factor it. Or theoretically, you could factor it. I don't like factoring, but the instructions said factor, so we'll use the F word. So I have t squared minus t minus 30. When I factor, I need t times t to be t squared, and I need two numbers that multiply to give negative 30, and then add to give negative 1. And so 5 and 6 multiply to 30, and their difference is 1. So I'm going to roll with 5 and 6. So my factoring of t squared minus t minus 30 is t plus 5 times t minus 6. And all that is still equal to 0. Now, we have negative 16 multiplied by t plus 5 multiplied by t minus 6. And one of the things that I know in this world is that if I multiply a few numbers together and I get a 0, one of them has to be 0. This is not the case if I multiply some numbers together to get 7. That doesn't force one of these to be 7. So now, if we're using nice numbers, yes, but we're using real numbers, so they could be hairy and goofy, and they could be pi and e and whatever. So we know that either negative 16 is 0, but it's not. I'm going to write it anyway. Either negative 16 is 0, or t plus 5 is 0, or t minus 6 is 0. So we'll mark off that negative 16 equals 0 because that's just nonsense. If t plus 5 is 0, that means t equals negative 5. And if t minus 6 is 0, that means t equals 6. The whole point of the question is, how many seconds does it take for him to hit the water? So does it take him negative 5 seconds to hit the water? Or does it take him 6 seconds to hit the water? Well, unless he's really cool and has a DeLorean, where's my DeLorean? He is not going to be hitting the water at negative 5 seconds. He's going to be hitting the water at 6 seconds. So at 6 seconds, after 6 seconds, and then we write it down. What was it? CDC is what I heard today. After 6 seconds, Jason hits the water. So what I heard today was CDC, which is, okay, I will not mention something that I don't have the details on. I'm going to have to find out what that is. But it had something to do with, like, write down, give the solution of the problem, and then give the description or the details. Maybe that's what it was, details. And then like a conclusion or something like that. So it was like the consequence details. Anyway, the answer, the details involved in the answer, and then like a concluding statement. So after 6 seconds, Jason hits the water. That's our final concluding statement. Now, and my Google Hangouts is still kind of fuzzy. So let me get that a little bit. Ooh, I like that. Okay, way better. Okay, so that is, you know what? Somebody's charged me for saying so. The other problem.
It's 7:30.
It's 7:30. So we got to wrap this up. The other problem was this toy rocket. If a toy rocket is launched vertically upward from ground level with an initial velocity of 128 feet per second, then its height h after t seconds is given by this crazy equation that uses another negative 16. So, and the questions are, how long will it take the rocket to return to the ground? Again, coming back down, right? And after how many seconds will the rocket be 112 feet above the ground? We have a quadratic equation. We have h of t equals negative 16t squared plus 128t. The initial velocity is 128 feet per second. Well, that's represented in the equation or the formula. We don't need to bother with that. That's just superfluous information. It's launched from the ground, so at time 0, it's at height 0. That's kind of important. That's a point on the graph, by the way. The other point you want is the point of some number time, some number of seconds with 112 feet. So it'll be, I don't know, like 10, 112. How long will it take for the rocket to return to the ground? There we have it again. So at 0 time, we are at 0 height, but also at time is 30 seconds or so, we'll be at 0 height because the rocket's going to do this number, right? Start out at 0, go up and come down to 0. So on the page here in Google Hangouts, look like that. Here is time 0 and height 0. And here is time question mark and height, again 0. This is where we're going to take our equation h of t equals negative 16t squared plus 16t, whoop, no, I'm looking at the wrong one. Negative 16t squared plus 128t. I want height equals 0 for this piece, for the piece where I'm looking for time when it hits the ground. And I notice here, 128, I can factor out negative 16t, and I get t plus 128, 16, 32, 64, 128. So that's 8. Yes, t minus 8. So now I have negative 16 equals 0. Ridiculous. T equals 0. We already knew that, right? Or t minus 8 equals 0, which gives us t equals 8. So after 8 seconds, it hits the ground. We can take the same formula, h of t equals negative 16t squared. Don't forget we are on mth4.co/MHY, math hack yak -pi. Negative 16t squared plus 128t. And I want to know at how many seconds does it take for the rocket to be 112 feet above the ground? 112 feet above the ground means its height is 112. So I'm going to do 112 in for the height. So I have 112 equals negative 16t squared. We have this solve for 112, but I don't want to solve it for 112, right? I want to solve it for t, and I want, in order to do that fancy thing where you split them up and you set them equal to 0, you have to get all the stuff on one side and then 0 on the other side. So let me get the husband. You get the dog, he's whining. Okay. I have 112 equals negative 16t squared plus 128t. I'm going to subtract 112 from both sides. So I have 0 equals negative 16t squared plus 128t minus 112. So now I can do some factoring. 112 divisible by 16. Didn't work on this problem before, so I'm going to play with it. 112 is 56 twice. 56 is 28 twice. And 28 is 14 twice. And 14 is 7 twice. So 2, 4, 6, no, 2, 4, 8, 16. So if I factored out a negative 16 from this quadratic expression, I would get t squared minus, what do we say, 120? Oh, 8. Minus 8t plus 7. So much nicer little quadratic equation expression. So I have now either negative 16 is 0 or this other thing. You know what? We can still factor it a little bit more. So I need to look at this and go, I need two numbers that multiply to give me 7, positive 7, and somehow combine to give me negative 8. So -1 and -7 will multiply to give me +7 and add to give me -8. So I'm going to use t-1 and t-7, and all that's times -16. Now, we're ready to do the either 0 equals -16. It's not. 0 is t-1. If that were the case, then t would be 1. That feels good. Or 0 is t-7. And if that's the case, then t is 7. So the question is, at what time is this thing 112 feet in the air? Well, we know that at time 0, at 0 seconds and at 8 seconds, we are back down on the ground. So it makes sense that at 1 second and then back at 7 seconds, it's at 112 feet. So it starts at time 0. After a second, it goes up to 112. Then it keeps going and goes around. And then after 7 total seconds, it's at 112 again. And then it hits the ground at 8 seconds. And we are out of time on Math Hack Yak. I appreciate your patience for this incredible weirdness of the technology. Hopefully, even though I'm going to send this, I think the Google Hangout will go right to YouTube, but I will make sure to get this on. Maybe we could edit this before it goes up. I don't think so, but let's see. To watch this for the Google Hangouts people, to watch this, it is the old HTTP thing, and then mth4.co, like math 4, /mhy, like Math Hack Yak -replays. And then you can watch this one. So this is Math Hack Yak with @math4. If you have not gotten your Weird Al tickets for your city, go do it. If you are in Houston, let me know, and maybe we can go have dinner beforehand. I am Bon Crowder. This is #MathHackYak with all kinds of technical strange things. But you know what? We got through it, and we actually did 2 problems. It's pretty exciting. So take care of yourself and each other. I don't know. What does that even mean? All right, y'all. I will see you tomorrow night, because tonight is Wednesday. So tomorrow night will be our last night. We may hit some more of the basic factoring or basic solving equations, not so much the word problems, but then we'll just go right into the actual mechanics of the quadratic expressions and equations and functions. So I will see y'all then. Bye. Have a good night. Oh, you get to stop this one. Stop broadcast.